Am I mic'd? I'm loud. I normally like to wait until like 1 minute past the stated start time, because then if people are like just grabbing coffee, they'll come in and they won't be sad that it says it's 3 o'clock on the dot and I've already gone. So just hang out here for a couple of minutes. But yeah, thank you all so much for being here. I hope you're enjoying Copenhagen Developer Festival so far. I definitely have been. Some of you may have seen me get up on stage and sing some Frozen at lunchtime, which might be the scariest thing I've ever done. Oh, thank you very much. Yeah, so very, very chuffed to be up alongside, some really, really good singers. And it's just really cool that we have this event where all these kind of weird talks and sort of bits of entertainment can come together. This evening we've got line breakers for you, so I'll be up on stage again with my French horn, and that should be really good fun. We've got some new songs this time, so hopefully I'll see some of you there in the audience. It's going to be a really good time. Not quite at 1 minute past yet. Give a little moment for any more people to just trickle in. Are we all sufficiently caffeinated so far? You're all sort of awake in this mid-afternoon of the middle day of the festival? All right, I'm going to start. Hi, everyone. Thanks so much for being here. My name is Eli, and I am here today to talk to you about authenticating your users over the web. This is. Ooh, will you work? Got to turn it on. That's crucial. This is me. This is the most text you'll see on any slide in this presentation. I'm not going to make you read walls of text or the SAML specification or anything. Yeah, I currently work as a developer advocate at a small cloud provider in Europe called Scaleway, based out of France. I like learning weird things and then getting up on stage and telling people about weird things. And you can find me online, unfortunately. No. For now, I'm on X, or whatever he's calling it this week. So, this talk is about user authentication. I'm going to take you through what authentication actually is, like kind of philosophically, like what is this problem that we're trying to solve, and why is it important. I'm going to talk about common ways that we have found of authenticating users, sort of tried and tested things, some things that are new and it's still in development and still sort of waiting for widespread adoption. And finally, I'm going to end by talking about what makes an authentication system good. When should you use one versus another? What kind of things do some do well and others don't do so well? Things like that. So, what is authentication? Well, let's say you're a web developer and you've built a web app. Ideally, you have at least one user, and you, as the person who's building this web app, will probably want to store some data about that user. Maybe you've got payment information that you'd like to store about them. And maybe there are things that only that user should be able to do, like post under a given handle. And you want to keep all of that data somewhere in your database of your web app. You want to have like sort of sovereignty over that data. But ideally, you have more than one user. You have quite a lot of users. And if you're storing one person's sort of their data and things that only they are allowed to do, you need to make sure that only that person is able to access their stuff. You don't want all the other people having access to everyone's stuff. And in order to do that, you need some way of defining who a person is within your system. So, a bit of user story here. We all know and love the user stories. As a web service provider, I want to verify the given user, so a person, corresponds to an identity, a programming idea, an identity, so that they can appropriately access data and actions based on that identity, who my program thinks that person is. Now, identity, it turns out, it's really hard to define. What makes me as a person different from another person is actually, like, philosophically, a really hard problem. We could spend hours and hours talking about what it means to be different from another human being and how do we determine that. But we're programmers, and what we do is we use abstractions. But like any abstraction, these can leak. They're only ever approximate. So here are some abstractions that we use. You've got username and password. You've got biometrics. You've got single sign-on with existing accounts that you have with other web providers. You've got things like Duo, and then you've got things like one-time passwords. And these are all abstractions that we have for saying this is who a person is. They have access to some knowledge or their fingerprint, or an object, like like your phone, for example. And when you're building a web app, this can all get a little bit overwhelming. How do you know which one to choose? Do you have to understand how all of them work in depth to make a well-informed decision? Well, if you decide that you do, this talk is essentially a jumping-off point for understanding how, on a high level, a lot of these things work, and going a little bit further in depth into a couple of them that I personally find really interesting. So, let's start with a well-known example, the username and password. How this works is as follows. You've got your user, you've got the front end of a web app that they interact with, and that web app is backed by a server somewhere. And this has your database, and it has your business logic and all of this stuff. So the user goes to the web app, and they want to log in, and they put in their username and password. That is then sent on to the server. The server is able to verify that that information is correct, corresponds to a user, and that that user should then be allowed to log in to their account. And that's what happens. Now, here, the abstraction we're using, the proxy for identity we're using, is knowledge of a secret, knowledge of a password, like knowledge that lives in your head, crucially, that you have to remember as a human being. So it's really important that when we use knowledge as a proxy for identity, that we keep track of who actually has access to that knowledge. Obviously, the user has to. That's the whole point. It needs to pass through the front end. But whether or not we consider that to be equivalent to the front end knowing it, is that a potential point of that knowledge leaking out into the world? Depends on your implementation, right? And then there's the server. So the server is pretty interesting as a thing when you think about passwords. And what I'm about to say is probably well known to a lot of you, but it's worth going through to really investigate what we're doing and why we do it when we store passwords. So the server has a couple of responsibilities. It needs to be able to verify that the user's password is correct, and it needs to protect that password from leaking out into the outside world. Because that knowledge is a proxy for identity, and if we let that knowledge leak out, then anybody can claim access to that identity, and that's bad. So a naive approach might just be to store them as records in a database. Now this is bad, obviously, because your database is somebody gets access to it, and they have all of these records. So we don't do this. What we do instead is we obfuscate things. And we use hash functions, which are one-way functions, where given the same input, you'll always get the same output, but you can't reverse them. So looking at the hash of a password does not let me recover the original password. You'd have to do things like looking up a list of values and matching them back to what the original values were. So let's say I happen to know what the hash of the password is. I could look and recognize that. But that's not the same as actually reversing the function itself. So we can do this. We can use hash functions. There's quite a few of them that people use. And what we can do instead is we can simply store the username and that hash password. And this is good. This is a good first step. It means that if your database is leaked, that password has not been leaked. But if you use common passwords, people might be able to reverse engineer sort of by looking at common hash functions with common passwords and go, I recognize that one. They've got password 123, and it's been hashed with this function. Another thing that makes this vulnerable is that if your entire database is dropped and you've used the same hash function for all of your passwords, that's an extra sort of point of commonality that an attacker could use to reverse engineer passwords. So we don't do that either. What we do instead is we add a little bit of data at the end or at the beginning of passwords, doesn't really matter, and we hash that whole string concatenated together. And what we do is, this is called a salted hash, and that little bit in pink is called the salt. And we can store that as part of the database record. So when we get the password in, the server goes, OK, I need to add that little bit that's before the $sign to the end of the password, then hash it, and it should match the bit that's after the $sign. And that way, without storing the password, and with also, we also make, essentially we're modifying the hash function, and that hash function can then be effectively different for every single user in your database. Because you don't use 7AF every time, you use random bits of data. And this is good. This gives you a lot of security against sort of brute forcing attacks, because now it takes a lot longer for a given attacker to go through your dropped database, the database that's been leaked out, and to discover reverse engineer passwords from them. However, if somebody really, really wants to get into your account and they get hold of your salted hash, they can still brute force it, and they can still sort of essentially reverse engineer what your password was for most passwords that are easily memorable by people. What you end up with, if you want a secure password, is things that look like this to start with. That's one of the hash values from earlier in the slides. And that's really hard to remember for an actual user. Like, this is pretty secure. This is a secure password, especially if it's being stored as a salted hash. But it's hard for a user to remember. And at the end of the day, the user has to be able to authenticate. When we think about the user, we can think about a couple of things. Users, we can forget our passwords. You know, how many times have I gone, oh, which one was it? I need to log into my Ravelry account or whatever. And you'd go through like 3 of the ones that I've used in various places, which is awful, awful InfoSec, I know. But we can forget our passwords. We can be tricked into giving away our passwords. This is phishing, or it can be done via social engineering, including phishing. So when you have a website that looks very much like the target website, and somebody puts in their password thinking it's the real thing, and now that knowledge is leaked out into the world, and the attacker has access to the identity on the real website, and we can be tempted to reuse a given strong password. I mean, I do this, it's not good, but the temptation is real, right? This is a human problem that we have, is that it's really hard to remember big, long strings of numbers. So, how can we do better? Well, one way that we've come up with of doing better is multi-factor authentication, or, as I like to put it, my one nod to the title of this talk, you shall not password, which is essentially using more proxies at the same time. To mitigate the risk of a single abstraction, like knowledge of a password, failing, we can use multiple abstractions at once, and we require them all to succeed at the same time. So we commonly divide up authentication factors into 3 categories. You've got things you know, like a password, things that live in your head, things you have, physical objects that you have access to, like a phone or a hardware token, and then things that you are, so biometrics, essentially. And that last category is pretty interesting because you can't actually transmit that over the web. It's really hard to sort of transmit, like my Google account, let's say, isn't locked with my actual fingerprint. It's locked with a hardware signature from the fingerprint sensor. We'll get into that later. But essentially, these are 3 categories of proxy for identity that we use. When you're doing multi-factor authentication, you could require 2 things that the user knows. But if an attacker is able to steal one thing out of somebody's head through phishing, social engineering, whatever, they might be able to use the exact same methodology to do the same a second time with a different piece of knowledge. So it's always better to mix and match and have something you know and something you have and something you are, so on and so forth. So it's better to do the latter, because then you mitigate the risk of a single strategy of attack succeeding multiple times. So, what are some options for multi-factor authentication? The first one is my favorite, hardware authentication tokens. And these look like this, YubiKey, for example. Most smartphones, I would say all smartphones and quite a lot of laptops now also have them built in. So if it's a USB key, it's what's called a roaming authenticator. And if it's built into a larger device, it's called a platform authenticator. And there are some subtle differences between them, but in broad terms, they essentially function the same. We'll get into platform authenticators a bit more later on in the talk. So the way that these things work to prove identity is public key cryptography. And you have a private key that you don't share with anyone, and a corresponding public key that you do share with the world. And if I want to verify that I know the private key, I can use it to cryptographically sign some message, send that with my hardware token, and send that to anybody who has knowledge of my public key, and they can use that public key to verify that the thing I sent to them was actually signed with that private key. And then they know that I have the private key. Essentially, you can prove ownership of a secret without giving away that secret. And this is very powerful. It allows you to have an identity that's essentially the private key, or it's the key pair, and to be able to asymmetrically prove who you are. And what a hardware token is essentially that private key baked in at a hardware level to a physical object that you own. So now we're talking about a secret that doesn't live in your head, you can't forget it, it's actually a piece of hardware. And the way that it works in practice is you go to your web app and you say, I'd like to log in, so you hit the login button. And the front end goes to the server and says, hey, this person wants to log in, and we've got on record that they have a hardware token associated with this account. Can you send me a authentication challenge, which is a message that has various pieces of data in it. Send that to me, and I will prompt the user to present their hardware device, whether that's over Bluetooth, by plugging it in, NFC. There's a couple different ways you can do this. And the web app goes, cool, where's your hardware token? Prove to me that you have this hardware token, and the user does that. They present it, and then that authentication challenge that's come all the way from the server goes onto that device and is processed in the hardware of that device, is cryptographically signed, sent back. Well, the user has to do a gesture to prompt the hardware key to do its thing. Like you have to use a fingerprint, or press a button, or use Face ID, and then the authentication challenge is signed, sent back to the client, passed all the way back to the server, which uses its knowledge of your public key to verify that cryptographic signing, goes, cool, they have the hardware token, let them in. Says to the web app, let them in, or the front end, rather. And then you're in. Hacker voice, I'm in. And this is how the flow works when you have a hardware token. And it's just public key cryptography. And there's a lot of really interesting stuff in the spec about how this actually works and the mechanics of preventing the hardware token from leaking the private key out into a computer that it's plugged into. So some advantages of this are that the device knows about the web service. That authentication challenge from the server contains data about the web service you're logging into. So Goggle.com can't steal your secrets. Phishing just doesn't work anymore because the hardware token can verify that the request is coming from a legitimate web service that it knows about. The private key never leaves that device. All that processing is done on the device itself. Some really, really cool hardware stuff going on in there. Really cool crypto circuits. I forget the terminology, but it's really, really interesting. So your authentication challenge comes into the token, it is signed on device, and the signed response is sent back. None of that happens on the device, the computer that you're using to log in, right? The device requires the user to be present, to press a button, to use fingerprints, so hit the button, fingerprint on your phone. And what this means is that if you leave a device plugged in to a computer, a YubiKey, A, the private key never leaves the device, so it can't be got out through malware, and B, if you have some malware on your computer that's like spamming the token with loads of requests in order to try and reverse engineer the private key, it won't work unless you're there pressing the button to make it do the thing every time. So this is a pretty strong protection against vulnerabilities in the hardware that your token interfaces with. Downsides, though. They're expensive. They're not accessible to a lot of people. Lots of people don't want to have to buy a USB that they can lose really easily. I mean, you can lose them very easily, I would know. And yeah, that's the other thing. Yeah, you can lose them. So they're not actually very usable a lot of the time. I want to log into my work Google account, but I left my USB at home, and now I left my YubiKey at home, and now it's a whole thing, So this is some drawbacks with them. That's why we haven't seen sort of widespread mainstream adoption of these. You see them mostly among software developers. But we do have them built into a lot of our smartphones now, and this is mainstream and widespread adoption of hardware tokens. So whenever you have your banking app and you need to verify a transaction and you use your fingerprint, that's actually, that's the verification gesture for the hardware token that's built into your phone. So that's what's happening there. And these are getting more and more use with passkeys, which I will talk about later in this talk. So we've got one-time passwords. I'm going to speed up a little bit because I realized that I'm going slower than I intended. So one-time passwords, the way that these work, you'll probably, has anyone in this room not used these before? Yeah, right? We all know what these are. You've got a phone, code on your phone or in your email, whatever. So you go to log into your web app, and you say, I'd like to log in, please. The web app goes to the server and says, please generate for me a code. You can also do this in a time-based way. That's how Google Authenticator works, is it factors in the current time to generate codes. And that's where they change every 60 seconds or 30 seconds. The server says, here's a code. Let me send it to the phone number that I have on file, and the user can look at that, enter it in, and be verified. And this is something you have. The user has access to this phone, and that's the proxy that we're using. However, you can clone SIMs. This is not hard. The amount of security that goes on in phone numbers across networks is shockingly low, like really, really low. If anybody knows about this, you know what I'm talking about. Like it's quite scary, actually. So it's really, really easy to gain access to text that somebody else is receiving. And that makes SMS-based one-time passwords not very secure. They're better than nothing, but they're not secure. Things like Google Authenticator are much better methods for doing this. Doing this over email is much better. You can also lose your phone. I had a phone get run over once. Dropped it in the middle of the road, and I came back like 5 minutes later, realizing that I'd lost it. It was faintly buzzing in the middle of the road. It was heartbreaking. And then what do? You're locked out of your accounts because you can't use your phone to authenticate with them anymore. So this is also a problem. Magic Link Login is very similar to a one-time code, and the way that it works is you have, the Slack does this. Has anyone not seen this before? Cool. Preaching to the choir. Works very similarly to one-time passwords. You put in your email, it says send you a link. Server says, cool, let me send a link to an authenticated session to the email address we have on file for you. Goes to your email, you click it, it takes you to an authenticated session. And this is really usable because if you're using the web, you have an email address. This is really accessible to a lot of people. It doesn't require you to have a smartphone. It doesn't require you to have phone signal. It just requires you to have internet, which you presumably already do because you're trying to log into an online service. It also, just by clicking on a link, you can't fat finger and type the wrong code. I'm typing on my phone the 6-digit code and I get it wrong and it's frustrating and it's a whole pain in the ass. That doesn't happen here. You are relying on the security of your mail server when you do this. If someone can intercept at this stage, get the link and access it before you, they'll be into your account. So, a lot of the time we rely on things like Gmail. Their security budget is bigger than any web app probably that you use that's not made by Google, for example. So that's not a particularly big security hole, but it is worth considering if you're, running your own mail server. So that's how Magic Link Login works. Yeah, people have emails. It's widely accessible. However, you can get locked out of your email. When I worked at my last job at Anvil, we had a lot of people who signed up with student accounts who then lost access to them because they graduated. And getting back into their accounts where their email was the primary identifier was actually quite technically difficult sometimes. So that's something to be aware of as well. Now, we've gone through a few methods of multi-factor authentication. Think about how many online accounts you have, X, I'm on Mastodon, eBay, Facebook, all the random shops that I've ever logged into. And think about how much effort it would take to set up a multi-factor, a second authentication factor on all of those different sites. It's a lot of effort. People just simply aren't going to do that. That's a lot of overhead. It's a lot of user friction. Or, in a work context, think about how many accounts you have as part of your work as a developer. Slack, whatever code management source you use, your HR tool, like maybe Figma or something, or your whiteboarding tools, or Zoom, all of these different things. And if you are a sysadmin for all of those, imagine setting up, maintaining, and clearing away when an employee leaves, second factors for all of those things. Absolute nightmare, just an incredibly complex task to do. So, we would like to have something better than this, something more usable than this. It would be really nice if we could just have one account that we signed into, and then all of our other things kind of piggybacked off that. And that's what single sign-on is. It's essentially the idea that you have service providers, which are the apps that we've been talking about, so things like the shop where I go and buy all my yarn, or, Hacker News or something. And then you also have a web service provider that what they do for you is provide an identity. So Google, for example, you've got Microsoft, GitHub does this, Facebook, you can do this with Facebook. You used to be able to do it with Twitter. Don't know if that's still true. And the identity provider handles the authentication on behalf of the service provider. So the way that this works is you have an identity provider that this is where your identity lives. It provides a central place for you to do things like use strong authentication factors and to make updates to things like your name or your address or your payment details, for example. And then lots of other service providers will rely on that identity provided by the identity provider. Now, this is great because, you can centralize things like your security and updates to your name and your details and things like this. However, and the way that it works is like this. So you've got your service provider. I've gone to my yarn shop. Let's say I want to buy some more wool. And I said I want to log in so that I can look at all of the things that I've got on my wish list and in my shopping basket. And the service provider says, cool, I noticed that you log in with Google. Let me send you to Google. That's your identity provider. And you'll have to authenticate there with whatever method you have chosen for your Google account. So you do that, and you're authenticated with your identity provider. Your identity provider then redirects you back to the service provider along with some kind of token of proof of your identity. And what the token actually is depends on the mechanisms used for this. But some piece of data that the service provider can look at, can parse, and use to verify that you are who you said you were. And then you're logged in. And that's it. It's just delegating authentication to a third party. That's what SSO is. It's really that simple. Where it gets tricky is the implementations. So we'll talk about that in a moment. It's great because web services now don't need to store your credentials. All that guff about storing passwords and salted hashes, just don't do that. Just hand it over to Google. Users don't need to remember lots of passwords. You have one account. You have maybe one big long password, and you can use your hardware token in one place and gain the benefits across multiple places. However, if you lose that identity, let's say Google is compromised, suddenly all of those identities that were relying on it are also compromised. So you're putting all your eggs in one basket somewhat. However, a lot of these big identity providers, they're baskets with big security budgets. So that's a reasonable trade-off. So this is the fun stuff, how we can actually implement SSO. There are two main methods that I'm going to talk about. There's SAML, which stands for Security Assertion Markup Language, and OpenID Connect. Right, SAML. I love this section. Who here has worked with SAML before? My condolences. I love this. I spent days and days reading the SAML specs and just turning my head inside out, being like, how is this working? So SAML follows the method, the sort of a broad overview that I just talked about, where you get redirected back and forth in order to authenticate. And when you want to log into a SAML service provider, let's say your HR system at work, you go, I'd like to log in. And then you are redirected to the identity provider for that SAML identity. And you're redirected in your browser. And what's sent along with you from the service provider is a thing called an authentication request. And this contains data about what the service is you're trying to log into, who you're trying to log in as, what maybe method that you've tried to log in with, like let's say you tried to use a password or something. Sorry, that's not correct. Just who you are and what you're trying to log into. And then what happens is that is cryptographically signed by a certificate on the part of the service provider. The service provider said, as proof of who I am, this web app, I'm going to sign this request with my public key, with my certificate, my like SSL certificate, for example. And the identity provider has knowledge of that public key, can decrypt that and parse it and say, okay, this person's trying to log into their HR system, and I am going to make them authenticate here with me, the identity provider. So you do that, and then the user is redirected back in their browser, back to the service provider, along with a SAML authentication assertion. And this is where you have data about what the person is allowed to do and the methods that was used to log in. So let's say that you use a hardware token at the identity provider. That might be part of the SAML assertion. And that is also cryptographically signed by a certificate belonging to the identity provider. And the SAML service provider has knowledge of that public key associated with it, is able to decrypt it, use it, verify it, log the user in. Now, I've specifically called out cryptographic signing here as a thing that is it's necessary because you have to have the service provider and the identity provider able to trust each other's identities. What's going on? Oh yeah, user is logged in. I had one more slide that I forgot about. One really interesting thing about this is it's all happening via user browser redirects. The two entities don't talk directly to each other. It's all browser redirects with attached XML data, essentially. And that means that your identity provider doesn't have to be on the public web. It can be in an air-gapped network, or I suppose not air-gapped, but it can be in a network that's running in your own company infrastructure. And you can use that to log into web accounts on the public web, as long as you're on the network that has access to the identity provider. That's pretty cool. I don't know how useful that is ever, really, but it's neat that you can do it. The reason I brought up cryptographic signing is because signing XML data is really, really, really hard, and I will show you why. Here are 2 bits of SAML code, data. They mean the same thing. But if you write a cryptographic signature, if you generate a cryptographic signature over the 2 of them, you'll get 2 different things, because cryptographic signing happens over byte strings, not over semantic data. Semantically, they're the same, but as strings, they're different. And they're both valid SAML, even though obviously we'd really prefer the first one, right? So they both mean the SAML issuer is whatever's in between those brackets. So when we have two bits of SAML that mean the same thing but are written differently, we'd really like to extract that semantic data and sort of have the signing work over the shared meaning that they have so that we can have the same signature generated for two things that mean the same thing. We'd like some process that extracts that semantic data, and that process is called canonicalization. You can put SAML data into canonical forms. But the issue with this, so then you canonicalize all your data and then you generate a signature over it, and that means that you can actually understand that the signatures refer to the same data that you were sent. However, your service provider and your identity provider have to agree on the canonicalization algorithm that you're using to do this, and there's not just one. There's a bunch of them, and there isn't an industry standard. They're also really, really hard to do, and this is complicated by the fact that there is no formal structure for SAML authentication assertions and requests. You can have multiple authentication requests within the same SAML message. It's an absolute trash fire over there. It's great. So SAML is really, really complicated to get right. But if you do get it right, it's pretty secure, and it's pretty usable. It's, click a button, go to the place you sign in, and now you're in. So the other way that we do SSO, and this is what you'll all have probably used in your everyday life, is OpenID Connect. And this, again, follows a very similar path with some differences. And if you've ever seen a dialog that looks like this, you've used it. This is OpenID Connect. So OIDC uses JSON web tokens rather than XML for sort of tokens of proof of who you are and requests and so on and so forth. And the difference here is that JSON web tokens do have canonical forms. There are golden paths for encrypting them, canonicalizing them, and parsing them. Tokens are parsed by the service provider. So when you log back, when you are sent back to your service provider along with a token of, yes, this user logged in, the service provider can understand that and say, yeah, cool, I understand who this user is. But they can also reach back out to the identity provider to verify them. So there's an extra layer of security there in that they can reach out to contact the identity provider directly and verify that tokens are actually valid. This means that your OIDC server cannot be it has to be on the public web or has to be accessible directly for the two entities to talk to each other, unlike SAML. The way that this works is you have your user, go to your service provider and you say, I would like to log into, I don't know, Sessionize. I'm a speaker, I use Sessionize. And I log in with Google. So I say, I'd like to log in. And then Sessionize sends me to Google, and it sends me to the authorization endpoint of Google's OIDC server. And here is where I log in. I verify my identity with, my fingerprint, et cetera, so on. And then what happens is the server sends me back to the service provider with an authorization code, and this is just like a string. And that authorization code corresponds to a record in the database in the OIDC server. And from this point onwards, my job as the user is done. All the communication happens between the two entities. So the service provider sends that auth code back to the server to a token endpoint. It says, I've got this authorization code. Can you give me a token? And the server goes and looks up that authorization code in its database and says, sure, I can verify that this is a legitimate thing that you're asking for. Let me give you a token representing that login event of that user. And that token is called an ID token. It's not really a token in the same way that bearer tokens are tokens. It's more a record of an authentication event. That gets sent back to the service provider. The service provider can parse it and say, yeah, Eli logged in with Google, and this is their account, and this is the account that I have associated with them, so they can log into their Sessionize and submit a talk for NDC London, right? And at that point, the web service could let me just log in. It doesn't have to do anything further, but if it wants to, it can take that ID token and it can send it to an introspection endpoint on that server for extra security that it is really a valid token, like maybe they want to check if it's expired. And that introspection endpoint can give the service provider more data about the user who logged in, the user who is referred to in that authentication event that the token represents. And the server can send back, yeah, this token is still valid, or no, this token isn't valid anymore. And at that point, the service provider can be really, really confident that you are who you say you are according to a trusted identity provider. Any questions? I feel like that's the most complicated setup, that's the most complicated flow that we have in this talk. Question? Sorry?
Can it work for applications, as application signing, where it's not a user, but a service?
Oh, okay, so a service can use this. So that's one. The question is it possible for applications to use this and not just users? That's what OAuth is, and OIDC is built on top of OAuth. So OAuth is built for applications to have access to like resources. Maybe, do you want to let Dropbox access your photos in Google Drive or whatever? And that's the mechanism that OIDC is built on top of. It's like a layer. You can use OAuth directly for authentication, but it's full of footguns. It's really easy to do it wrong and leave gaps in security. So that's why OIDC was created as basically syntactic sugar on top of OAuth to make this particular use case much easier and more seamless. So yes, that's also a different talk, which I would love to write, but I'm happy to talk about it with you afterwards. OAuth is really, really cool and kind of hard to understand. Or I found it very hard to understand when I got into it. Cool. So that's OIDC. And in this method, the two entities communicate directly. This means that they both have to be able to actually talk to each other. They have to be able to do that. But it also gives you an extra layer of security against spoof tokens, because the service provider can always go, I have this token. Let me go and check with the person who supposedly issued it to me, the identity provider, that it's legit. You can also extend this. There's a user info endpoint. Let's say I'm a service provider, I've got a token, and I'd like to know this user's email. I can actually go and ask and see if I'm allowed to know that about the user at this endpoint. So that's particularly useful for like, oh, would you like to let this web app access your payment details that we have stored in Google, for example. So it's really nice for providing sort of a good user experience and better security. Right, passkeys. I'm glad I've left myself enough time to really talk about these, because these are really cool. So passkeys are quite new. They don't have widespread adoption yet, but they are mature enough that I no longer can leave them out of this talk. And they're very, very cool. So here's this logo. If you see this logo, use passkeys. It's like everywhere you talk about passkeys, you must use this logo. And I really hope they don't come after me for like editing it into the colors of these slides, but here we are. Passkeys are an initiative that's currently being run by Google, Microsoft, and Apple, so some big identity providers. And what they are allowing you to use hardware authentication tokens built into your phone, or with laptop without loss of generality, platform authenticators that are registered to your Google account, your Microsoft account, so on. So I've got an Android phone. The platform authenticator on that phone is registered to my Google account. Google knows that that authenticator belongs to me. And essentially using those to daisy chain security to a bunch of key pairs that are stored in the cloud. So every time you want to create a new account somewhere, you go, I'd like to create a new key pair that lives in my Google Cloud, again, without loss of generality, and which will be encrypted with the password to my Google account. So we haven't quite got away from passwords entirely, but we might move towards a model where passwords essentially become encryption keys for lots of key pairs that live in your cloud account. And then when you want to log in somewhere, you log in with your phone, and you can log in with your phone or your laptop, and there's various different flows for using the hardware platform authenticator on a device that you have that's tied to your account to unlock, decrypt, and use the individual key pairs that are associated with the specific service providers. Does that make sense? It's quite circuitous, or it can be. Okay, no raised hands. So this is how that flow looks. I've kind of got rid of the user here, essentially. But I, as a user, I go to my web app, and I say I'd like to log in, again, to Sessionize, let's say. Let's say that I'm using this instead of OIDC for it. And I have previously logged into Sessionize and said I want to generate a key pair, a passkey, that lives in my Google Cloud account, that is related to this account and that I can use to authenticate. And so what happens when I go to log in, let's say from a new device, I go, Sessionize, the web app, goes to, it knows that I have a passkey that's used in an authentication method. So it goes to Google, this passkey logo in the middle represents the service, the identity provider, and the store of key pairs that it has in the cloud, encrypted with my password. It goes to Google and it says, Eli wants to log in here. Can I use the key pair that you have on file for them to authenticate in the same flow that you do with like hardware tokens? It's like a virtual hardware token in the cloud. And the way that that virtual hardware token is unlocked and ready to be used is that Google then goes to my phone and says, you said you wanted to log into Sessionize. Before I can unlock and use the passkey that you have stored for it, you need to authenticate on your device with your fingerprint, with your Face ID, by making that gesture to make your hardware token, to authenticate with your hardware token that's on your phone. And when you do that, you do the gesture that says, yes, I'm here, and I want to unlock these passkeys. That consent that is cryptographically secured consent, because again, this is an authentication challenge that's being signed by your hardware token in the same way that it was with the YubiKey example we saw. That signed challenge is sent back to Google, and Google goes, cool, I can verify that the user said yes, they authenticated on their device that I know belongs to them. I can be cryptographically very confident in this because it's using a hardware token. And now, I know that I'm allowed to decrypt the passkey I have stored in the cloud and use that to log in to Sessionize. And that's how that works. And it took me the longest time, and now you're logged in, it took me the longest time to understand how you could have a passkey, a hardware token that was on your phone that was somehow being used across lots of, through the cloud, while that private key wasn't ever leaving the device. And it's because the passkeys that you're using to log into your service providers are not the same ones as the one that lives on your platform device. That's simply used as a check. It's daisy chaining key pairs, essentially. So that's how that works. And passkeys have a few different qualities that are interesting to talk about. It protects against device loss because what you can do is you can register multiple hardware tokens to your Google Cloud account. So I could register another YubiKey to my Google Cloud account and use that instead of my phone to be able to unlock the store of passkeys that lived in the cloud. Suddenly, all of these hardware, these sort of virtual hardware tokens that live in the cloud, because they're virtual, I can't lose them. They're backed by all of the security of Google's cloud, essentially. And again, without loss of generality, your identity provider of choice. If I lose my phone, suddenly I haven't lost access to all those accounts. As long as I have a way to get into my account and register a hardware authenticator, I can keep using those passkeys that already exist. I don't have to change them. It also uses user verification as opposed to user presence. So user presence is if I have to press a button. Somebody's there. But user verification is when you use biometrics. Somebody's there, and it's specifically this person. So that's when you get the interesting thing of you're using biometrics not just as a gesture of sort of somebody is here and is saying, yes, you can do this, but the person I care about is here and saying, yes, you can do this. And these are terms that you'll see in sort of security world if you're interested in stuff like user verification and user presence and user sort of various different things like this. And it's better to have verification. It's better to have verification than presence. Just because somebody's there pressing a button doesn't mean it's the person that you actually care about. But if you have biometrics, that's what you get. This technology is currently dependent on big identity providers. So unlike open source password managers, for example, we don't currently, I believe, have open source passkey storage generation. I think it's coming. I think Bitwarden is working on it. There's a few. I haven't looked in a month or so to see if there's been updates in that arena, but that is going to happen. You are not going to eventually be dependent on big corporate clouds and identity providers for using this technology. And what that will also get you is cross-platform passkeys. Because at the moment, if I want to use Apple passkeys, I can't use them on an Android phone because that platform authenticator is not tied into my Apple account. So at the moment, cross-platform passkeys are hard to do if you're bought into one ecosystem but you want to use a device that's not a part of that ecosystem, for example. But that is changing. That's coming very soon, and it's going to be very exciting. And in general, it's always really good when security stuff happens sort of out in the open, like you've got open source versions, because it means that very, very smart people can look at it and verify that it's good, right? There's a reason that private cryptography isn't like a thing. It's because like it's good to have it done out in the open so that all like the experts can come and look at it and go, yeah, that's secure actually, that's good enough. So that's really cool. I really like passkeys. I think they're technically interesting and they have a lot of good usability features. So, final section, we have 15 odd minutes left, and we won't go to full time. This is about like 5-10 minutes. What makes an authentication system good? We've talked about lots of different ways to authenticate people, various security postures of them and how they work. But at the end of the day, it doesn't really matter unless you've got users that use your thing and it works for them. So obviously we need security. If your authentication system isn't secure, you might as well not have one, right? And this is where I'd like to come back to the humble username and password. If you've got username or passwords that look like this, that's actually quite secure. But the thing is that to use them securely, you have to know loads and loads and loads and loads of them. And this is hard. And password managers help, but they only go so far. And they also introduce big points of, single points of failure. So we've had LastPass got popped. Like, it happens again and again every couple of years. But if implemented correctly, and if the user remembers 50 passwords that look like hashed values to begin with, it's secure. But that's not usable, right? You end up with people writing things down, reusing passwords, so on and so forth. If something is hard to use securely, it's insecure because people will end up bypassing the ways in which it is secure. So you have to consider not only security, but usability. And which one is this? Oh, yeah. You can't trust users to make good decisions. And I once knew a brilliant, brilliant engineer, and he pasted his master password into Slack. It happens to the best of us. You cannot rely on users behaving perfectly. If your users have to behave perfectly for your system to work, then it's a bad system. So we need both security and ease of use when we're designing an authentication system. And I'd like to come back here to SAML. If implemented correctly, this is both secure and easy for the end user. But it's incredibly hard to implement correctly. I would put it to you that there is not a single secure, really secure SAML implementation out there. If something is hard to implement securely for us as developers, then it's also going to be insecure. So actually there's a third pillar here that sometimes I think doesn't get brought up in these conversations, and it's ease of implementation. If something's hard for us to build right, we're going to build it wrong, and that's not good enough. So we need to have things that are easy to use, easy to build, and secure by design. And for that reason, I like passkeys. If I'm able to stand up here and kind of explain in broad terms how they work, that's good. That's a good sign that conceptually they're easy enough to understand how they work and to work with them as developers. There are golden paths being developed for their use. We've got very good engineers at lots of these big places, these big cloud identity providers, and also on the open source side, working to make these things easy to use, easy to implement, and secure. So I don't normally, at the end of this talk, this is the first time I've thrown in like a conclusion of like, actually I really like this particular thing. Normally I've gone, oh, it's up to you, look at your constraints, everything's going to be different for different people. I really like passkeys. I think they're really interesting. I really encourage people to go away, read about them, see if you can get them set up with some of your accounts. Phil Nash, who is another speaker at NDC, he's not here right now, but he has a really great talk about them as well, which you can go away and look up. It was by watching his talk that I understood how they worked, like I had the light bulb moment. So I really encourage you to go and look that up for discussion of how they can be how the user experience of passkeys can be improved and streamlined, and you know, where the development is going with that. So that wraps me up. What have we learned? We've talked about what authentication actually is, you know, the idea of abstracting identity and using proxies, and why we need it, so other people don't get hold of your stuff and post as you on X or whatever. We talked about how we do it, lots and lots of different methods for doing it, and how we can choose between them and why it's difficult. And finally, we've talked about how to do authentication well, the things you have to consider, you know, security, ease of use, and even implementation, and usability mattering not only for the users, but for us as developers developing these systems. Thank you very much. Any questions? Any questions? Hang on, I'm going to come down just so I can definitely hear you. Oh, fantastic.
Hello. As a usual developer, I want to provide, for example, this what's the word session key? No, the keys you recommend. Passkeys. So if we need to support both Android lovers and iPhone lovers, do we need to support then both buttons? Log in with Google, log in with Apple?
Good question. So the question is, actually, no, you had a mic, so I don't need to repeat your question. Fantastic. I don't know. I would hope that, well, yeah, it depends, because if you've got passkeys stored in 2 different clouds, you're going to have to decide which one you want to use. It's not going to be as simple as living in the same cloud and this passkey was generated by Apple and that passkey was generated by Azure or whatever, your Microsoft account. Yeah, potentially. You might have multiple passkeys in multiple accounts. I can see that being the way that it goes. I can also see that being a point of friction that people want to reduce over time and development efforts going towards sort of homogenizing things in that way. I think it'll probably end up being a push and pull between, because obviously these big cloud providers, these big identity providers, they want their users to stay with them. They want to be sticky to their users. They don't want people becoming agnostic. They do in the sense that like making users happy is good and makes them stick around, but they're not necessarily going to make it easy for you to take all of your passkeys away from a given identity provider and put them in Bitwarden, for example, because it's not in their interest to do that. Like, not to get to like capitalism about it, but I see that being an ongoing source of friction for users, honestly, but it's no worse than a lot of the things we have now, I would say. And the rest of the benefits of passkeys, I think, make them still worthwhile. Does that answer your question?
Hello. Yeah, I wanted to ask that basically the passkey solution that was suggested is making the hardware key to the virtual cloud, like to be managed by these big corporations. And does that make it does that create a bigger point of failure that compared to I have a local password manager, when it fails, my stuff get hacked. But if the big company, they get hacked, then everyone using it with every account, it gets hacked, everything. Is that a risk that we are willing to take? We trust them that the chances is much lower than my account get hacked.
Yeah, so the question about, again, putting all your eggs in one basket in this way. It's no worse than storing your passwords with Chrome, I think, which I definitely do. Like, built-in password managers into your browser are really good and have opened up the idea of using a password manager to a lot of people, and this is kind of a natural extension of that. So one thing that I don't know if it's going to change or if it's been baked in so early into passkeys that it's kind of here to stay is the idea of your passkeys being encrypted with the password to your Google, Microsoft, Apple account. Because that is one protection against, let's say, the entire store of passkeys for a given region gets leaked, is that they have been encrypted with your password. And if that's a strong password, and in theory it should be because it might be the only one you actually ever need to use in the future, then that's decent protection against those key pairs being taken and used elsewhere, because they are encrypted at rest. And they're only decrypted when there's an active sort of, you have authenticated with your platform device and sort of very specific permissions to unlock that key pair has been given. Yeah, I think it's always a concern whenever you centralize your authentication is, well, what happens if I lose that thing that I'm building all of my, security infrastructure on top of? Is that a firm foundation? Yeah, I trust the security team at these big, well, maybe Microsoft less so, although that's probably heresy to say at an NDC conference, but the security at a lot of these places, I trust more so than, me running my own Bitwarden server somewhere, right? So, sorry, Vault Warden, I think is what it is when it's you run it yourself. But yeah, it's a good concern. It's a valid concern. There isn't really an answer to it. Does that? I was going to say there isn't an answer. Does that answer your question? But does that help? Was that useful? Any more? we can all run and get some coffee for the next sessions. All right, I'll let you go. Thank you so much for being here. I hope you continue to enjoy the rest of the conference. And yeah, come see us on stage this evening. Come and watch the line break, because it's going to be a great time.